Rex, thanks for sitting down with me today. Pleasure to sit down and chat.
Thanks for having me.
Rex, congratulations on receiving NAPB's Plant Breeding Impact Award. It's great to be recognized by your peers, I'm sure.
It's quite an honor indeed.
Much of the work that you've been doing on plant breeding is focused on corn. Mm-hmm. Lots to do with new breeding techniques, which, as we all know, have faced some challenges, and probably always will face some challenges. Can you do me a gigantic favor, and from your perspective, break down a little bit for those of us watching, those of us that aren't scientists, those of us that aren't plant breeders, to understand how those new technologies work, and why do you think there is some pushback within society today?
Well, the context of it is that corn breeders, plant breeders in general, have been looking for new tools in breeding all these years. In the early 1900s, there was this new tool called hybrids. Hybrid corn, quite unnatural if you think about it, in the sense that corn hybrid, as we would see in the field today, would never exist in nature. And then came the 1930s and 40s, and there were induced mutations and polyploidy, and then you had GMOs come to the forefront, and now there are what are called genome editing technologies that are coming to the fore and that are now available at the experimental stage. What genome editing is it's basically going into the genes of a plant and doing edits right there and then. You know, if you think of our English language, there are 26 letters in the English alphabet, and the arrangement of these letters plus punctuation and spacing gives us words and gives us information. In the same way, genes are DNA, and they have 4 bases abbreviated as A, T, C, and G, and the sequence of these 4 letters, if you would, of the code ultimately determine how a corn plant looks like. And if you make a mistake, let's say instead of typing seed world, you know, W is just on top of S, and you type weed world, and you'd like to make that mistake if you have a word processor, you'd simply do a search and replace. You'd probably search for world and see if there's something wrong close to it, and you change that. It's the same way with these new genome editing technologies. It allows us tools to go right into the genes and make either cuts, or we could paste, or we could do a slight edit of that content. And why it's a concern? Well, with any new tool, I think it's the unknown that brings concerns as to, will this technology be safe? If you think of GMOs, well, those concerns were there, and they still are. But they've been around for more than 20 years now, and grown on hundreds of millions of acres, and the record speaks for itself. So I think we'll find out more about these new tools, what they can do and what they can't do. The regulations will fall into place, and the next tool will come around.
And you know it will.
I know it will. Always has, always will.
Agreed.
Yeah.
Agreed. Corn has certainly seen a lot of investment over the years, and the trend is quite obvious. Significant increase in yield, significant increase in productivity. What are you working on now that you see as the next big thing? What's going to drive us to the next level?
Much of my work right now is more on methodology development of how do we make the breeding of corn as effective or as efficient as it can be. And what I've seen in my career is the appearance of DNA fingerprints or molecular markers. The same DNA fingerprint technology available for forensics, for crime, or for the human genome, we have that available for corn and other plants. And so to evaluate a corn hybrid for yield, typically a breeder might test it at, say, 8 locations for starters, and each location might cost $15, and so that's about $120 to evaluate a corn hybrid. When I started my career, the cost of fingerprinting that corn line was probably in the order of $300 to $400 per line. But now the technology has changed, so now it's about $15 or $10 or $20 per line. And so the idea now is that fingerprinting a line or a hybrid is a lot cheaper than it is to evaluate it for in the field. And so the idea is, how do we leverage this difference, this price differential? Not that field evaluation will go away. We obviously need field evaluations, but how do we leverage this availability of this new tool to make breeding more effective?
Right, excellent. genetic diversity is always a topic and included in corn, and it's one of the key focuses of the conference here
That's
at the
right.
NAPB meeting. You're going to do a presentation tomorrow speaking specifically on that. Few stages to a question. What are plant breeders doing today to help maintain that genetic diversity? And how does the genetic diversity within corn that seems to get talked about a lot, how does it compare to other key crops in the US?
Corn is by itself diverse, but the diversity, I think, in corn, at least what comes to the farmer's field, is getting less and less. Soybean is less diverse, I would think, than corn. And if you think about it, a breeder's job is actually to exhaust diversity within a population. Because if you cross two parents, what you want to do is to get the best possible progeny. And so if you get that best progeny, you've just exhausted the variation in that cross. And what you need is a constant inflow at the outset so that you have good products in the end and new diversity coming in at the very start. And so much of the diversity has been stored right now in seed banks, seed collections. We have one in Minnesota. Unfortunately, at least the one in Minnesota, it's more of a seed morgue than a seed bank, in the sense that what goes in there we forget about, because it's a long-term process to find good variation. Oftentimes this variation is hidden. There are gems in there that we need to pry a little bit and find. And so what we need are tools to better evaluate these accessions for hidden variation and to better see what's in there that's not out there right now. And I think, yeah, there are new tools and methodologies that are being developed. But an issue is that breeders are often looking at short-term gain. And the issue of genetic diversity is more of a long-term objective that is easy to forget.
Right.
And so that's why I think the topic for this conference is very timely and very meaningful to plant breeders.
Indeed, and technology continues to push us and push us and push us. Can you talk a little bit about how technology is enhancing what you plant breeders are doing today?
Yes, I call them power tools in plant breeding. So, guys like, a power saw and a power drill and so on, and we have what I call power tools in plant breeding. One power tool I talked about was DNA markers. Another would be double plot combines and bigger planters, faster computers, databases. The ability to grow corn year-round, for example, in a warm place like Puerto Rico or Hawaii has paid dividends because of being able to grow more generations per year and increase the gains per unit time. So again, these are the drivers. I mean, in a sense, many of them are not too fancy, but they get a job done.
Right. So I'm going to ask you to look into your crystal ball a little bit. If we look 5-10 years out, how is plant breeding going to be different in 5 to 10 years?
I think we'll see plant breeding even more so compared to today as more of a factory. I think in the major crops anyway, plant breeding is more or less like a factory. In a factory, you have your raw material. It comes through a manufacturing process. You have quality control, and you have a product in the end. And the same with plant breeding. Your raw material is your germplasm. It goes through a breeding process. There's quality control in terms of evaluations in the field or greenhouse or lab, and you come up with an improved variety. It has become quite specialized, and I think we'll see more of that specialization. Not to say that the art of plant breeding is completely out, but more so at least in the major field crop species. It's very much data-driven, and it operates like a factory, with the exception that we're working not with a plastic or steel, but with a biological organism. So when we cross two parents, we can't quite control what the progeny would be, but then that's part of the beauty of the breeding process as well.
Right. At your university, you're also teaching young folks plant breeding. Can you talk a little bit about some advice, some thoughts you might have? I know one of the main mantras of NAPB is to encourage and support young people into the field. Your thoughts?
Yeah, well, to be young again.
Yes.
My thoughts are a plant breeder needs to know plants needs to know the organism. I mean, there's things, more theoretical aspects of the field that somebody obviously has to know, but there's no substitute for knowing your subject well. In this case, your subject is the particular species that you're working with. I would say that more and more so, as I've mentioned, many of the breeding processes are increasingly data and information driven. So the ability to handle large amounts of data, get information from those data, and make breeding decisions will become increasingly important. And breeding is an operation, and so working with people skills, soft skills, are extremely important in this day and age when you have specializations and different teams within a breeding organization who need to communicate well together and work well together.
Right. Well said. Good advice. Good advice. Rex, thanks again very much for sitting down with me.
Thanks for having me.